Okay, so let's take a look at your homework from last night. Yeah, so Thursday's homework. What we would have gone over today in class if we had had it. So first on page 719, we already did number 28 in class. Or maybe that was 27. So we're going to start with number 28. So I already drew them to save me some time. So number 28 says two loads, 25 and 35 ohms each. One of them has a 65 volt potential across it, and it wants to know what's the potential difference across the second one. So from our R1 and our V1, we can find our I1. So I1 is just going to equal V1 over R1. So 65 volts over 25 ohms. And when you divide that out, you should get 2.6 amps. And because this is in series, all the currents are the same. So that means that that's also I2 and that's I total. So if we have I2 and we have R2, then we can find V2. So V2 is just equal to I2 R2. So 35 ohms times 2.6 amps, and that should be 91 volts. And then the second part of the question wants V total. So there's two ways we can find V total. We can either take our 65 volts that we have up here plus our 91 volts, V1 plus V2, and get our V total. And if we add those together, we get 156. Or you can get V total by doing I total, R total, which is 2.6 amps times 25 plus 35, which is 60. 2.6 amps times 60. Either way, you're going to get 156 volts for V total. Okay, so that's number 28 done. Number 29 gives us two resistors. One is 48 ohms, the other they want you to solve for it. They tell you V1 is 40 volts and they tell you V total is 75 volts. So we can get V2 right away because we know V2 should be 75 volts minus 40 because in series the voltage adds up. So this needs to be 35 volts when you subtract them. From R1 and V1 we can get I1. So I1 will be equal to V1 over R1. So 40 volts over 48 ohms. 8 goes into both of those, so this reduces to 5 over 6 amps, or 0.83 repeating amps. Remember that in parallel, currents are the same, so this is also I2. And so now we have V2 and we have I2, so we can find our R2. So R2 is just going to be equal to V2 divided by I2. So it's going to be equal to 35 volts divided by that 5 over 6 amps, leaving it as a fraction so I can do it in my head, because then you can flip it and multiply. 742. R2 is equal to 42 ohms. Okay, so number 29 is done. Number 30. Number 30, they give us two resistors again. They tell us the voltage in one is 56 volts. They tell us the current through the other is 7 amps. And they tell us the other resistance is 24 ohms. So if I2 is 7 amps, that means that I1 and I total are also 7 amps because in series all the currents equal. So we have all 7 amps. Now the two things they want you to find are R1 and V total. So if we have V1 and we have I1, we can get R1. So R1 will just be equal to V1 over I1. So it's 56 volts divided by the 7 amps. R1 is 8 ohms. Okay? V1, you have two choices. You can either find R total, which will be 8 plus 24. So R total will be, that's about 32 ohms, I believe. And then we can take that with I total and find V total. So you can do V total equals I total, R total, and multiply them together. The other option is to find our V2. So if you get V2, I2 times R2, and then add it to 56. Doing it either way, you should end up with, I think it's 224. Is that what 32 times 7 is? I think so. 224 volts. Okay, that's number 32. No, that's number 30. Number 31 is 3 resistors. Sorry, there we go. 3 resistors. They tell us R1 is 42 ohms. They tell us V2 is 111 volts. They tell us V total is 240 volts. And they tell us I total is 1.5 amps. So if I total is 1.5 amps, so is I1, so is I2, so is I3. So all of these are 1.5 amps. So from 1.5 amps, we can find our V1. So V1 is equal to I1 R1. So I1 was 1.5 amps. R1 was 40, I think it's 42. Yeah, 42 ohms. So this should be equal to 63 volts, I believe. Okay, so we have V1, we have V2. That means we can now find V3, because in series, voltages add up. So V3 should be equal, oops, sorry, off the screen, should be equal to V total minus V1 minus V2. So 240 minus 111, so that's going to be 129, and then minus another 63, so that should be 66 volts. So V3 is 66 volts. We know I3 is 1.5 amps, so we can find R3. It's just equal to V3 over I3. So 66 volts over 1.5 amps. And when you do that, you get 44 ohms. Series resistors, series circuits are done. Easy, right? Okay, so now we're going to do the parallel ones, and I'll go through them in the second video to make sure you get them, because you need the series and parallel so that we can do the complex ones, which will be the third video. Okay, talk to you soon.